happy to have everybody here. Again, many different places in the world, so I won't say good morning or good evening, just welcome to our webinar. My name is Michelle Waite. This is our monthly webinar series for Skycatch. It is a series that we are just kicking off with this event today. We will be speaking throughout the year with industry professionals in many different areas and thought leaders from around the world. So welcome to our inaugural kickoff. We have today with us two veteran mine surveyors who are going to help us talk about and learn about the ins and outs of capturing good quality 3D mine surveys and how they interact with the team. We're going to make it an interactive presentation today, so this will be more of a roundtable sort of discussion. We invite anybody here to put your information into the Q&A or into the chat, and we will address your questions as it makes sense. And if we don't get to them, we'll be sure to follow up afterwards as well. So let's go ahead and get started, and I want to introduce everybody that's here today. We have Simon Jamieson, who's joining us from Australia. We have Kylan Borton joining us from Canada, Will Pryor from Skycatch in San Francisco, as well as myself sitting in San Francisco today also. So I'm going to let everybody introduce themselves, tell them a little bit about themselves and where they are and what their experience is. So Kylan, do you want to go ahead and get started?
Yeah, sure. Thanks for having me there, Michelle. Yeah, my name is Kylan Borton. I'm from Wawanesa, Manitoba, Canada originally. It's a beautiful small prairie town full of great people there. I think we had 489 in there when I was there, 488 when I left. So pretty small place. And yeah, so I headed out west to the mountains about 20 years ago, and now I live in Fernie, BC here. So I've been in surveying here for about 10 years now, doing some various jobs around the valley. So I was lucky enough to get in with a local company here, Align Surveys, that really helped pave the way for me and taught me all I know pretty much. And I'm very thankful for that opportunity. So that led to me to opportunity as a head surveyor for a contract company. So got me out of the valley a bit more up to northern Alberta, doing some rail grade work and that type of stuff there. So all along the way, I gained some mining experience and eventually got right into working with the mines. So lucky enough to work in various roles up the mine, whether it was geotech, coal quality technician, surveyor, obviously, and then even sampled a little bit of water up at the mines as well. So I got a bit broad base there, and so hopefully I can help people today with that. And something kind of different about me, I guess, that 10-year gap there from when I moved out here till I started surveying. I was a golf professional for 11 years, so something a little bit different. And then somehow it led to surveying at the mine.
Did the golf help with the surveying at all? Was there any relationship there?
Maybe one transferable skill there. I don't know, not too much.
Awesome. Thank you, Kylan. Appreciate you being here today, taking your time. Simon, why don't you tell us a little bit about yourself?
Yeah. Hi, everyone. My name's Simon Jamieson. So my surveying probably started back in 2010 when I graduated from RMIT in Melbourne, Victoria. I started off working as a land/engineering surveyor in Melbourne around regional Victoria. I worked in open cut mines both in Western Australia and in Queensland. Currently working as a mine surveyor up in an open cut mine up in central Queensland, and probably been using drones since early 2018 for data capturing purposes. So, and I've seen over just that short period of time how it's really changed our work up on the site. So, and a bit of a side note for anyone who's in Australia, I'm a very keen West Coast Eagles supporter, and for anyone over in North America, I'm a big Chicago Bears fan. So, sort of cover both sides there. So,
awesome. Thanks, Simon.
Nice.
And then we also have Will here with us today. Will, do you want to speak to yourself a little bit?
Sure. So I'm the manager of enterprise applications at Skycatch, and I started, with the company around 2013, basically building and operating our drones. So, when we started, you couldn't really go to the store and buy one; you had to build one. We tried to make it easier for for people to use drones, deploy them. We have an automated, basically automated data capture system. The arc of my career has really been from that, starting in mechanical engineering, moving to really talking to the folks in the field who use our systems, and then interfacing internally to meet the customer's needs. So I've been very fortunate to work with surveyors really around the globe. I like that, Kylan sort of identified, the surveying profession is like highly apprenticeship based. So I'm just really grateful for the surveyors, who've been willing to share, everything about geomatics with me. I take that information and I package it up to SkyCatch to sort of drive our product, and then share those best practices with some of our users. So I've been deployed, with SkyCatch systems on something like 4 or 5 continents. And yeah, when I'm not flying drones, I'm exploring the waters off of Northern California on my sailboat. So something distinctly analog, but lots of navigation challenges in there too. Kind of like I'm sure when Kylan was on the green, trying to estimate the distance to the pin.
Awesome. Thank you, Will. Thank you, all of you. So as I mentioned, we want to make this a very interactive discussion today. So we will be doing that. First, I want to just remind everybody that if you have any questions throughout this event, if you scroll over the bottom of your screen, Q&A or the chat feature, you can add your questions there. As we're going along, we'll be looking at those questions and addressing them as they make sense. And we will be recording, or we are recording this event, and we'll be sending this out after. So for anybody else that you would like to share it with, or those who were not able to make it today but signed up, we'll be sending it to you after the event. So just quickly though, for those of you who know nothing about SkyCatch, Will is going to give us a little overview, just a very quick overview before we get into the discussion.
Sure. Yeah. Thanks so much, Michelle. SkyCatch has been around since 2013, and really from day one, we've been focused on carrying cameras and capturing actionable data from the environment. As I mentioned before, in 2013, you couldn't buy a drone. You had to build one if you wanted to use one. And of course, learning how to use those was very difficult. Our original sort of reason for being was to create a auto landing drone, a remotely deployable drone, kind of like a Roomba that would go and fly and carry a camera. We did that, and found out that modeling these environments was really the best use case for drones at the time. If we think about the payloads that drones carry, I think cameras are still the most valuable payloads that drones have. We were very fortunate to work with some great, large companies, and learning a great deal about, geomatics and precision survey. One of those is Komatsu. Komatsu, the global company, basically the, sort of Toyota, if you will, of, earth moving equipment. As a Japanese company, they held us to a very high precision standard, and we learned a great deal about deploying early systems that we had, which use what I would call conventional survey systems, ground control points. So when you have to do a lot of surveying, like Kylan and Simon do, flying every day, multiple times a day, I know maybe dozens of times a day even, setting ground control was a very difficult process to control. There's a lot of coordination that has to happen in maintaining good ground control, right? We know that. So as we got to deploying with more and more users, we saw that we need a better way to control this accuracy. And in about 2018 or so is when we introduced our first RTK GPS integrated multi-rotor. So a mapping drone with a built-in camera, and was built to function exclusively around our high precision. It's actually a PPK system. So since then, we've really been focused on how to push the limit on accuracy with our high precision systems, and automation. Just like in the early days when we wanted to make it easy to fly a drone, easy to capture data. We have a product now that really makes it as easy as possible to capture high accuracy data, primarily relying on RTK and PPK on the drone. And for extra, high precision use cases, we do support using ground control as well. So, we have a kind of a connected suite of products. There's the data analytics package, which is where, data ends up after field survey. We do support processing as well. So we have both a cloud and local edge-based processing system. And we've been a drone manufacturer in the past. We made a few different generations of drones. Now we've seen some of the great companies that have huge presence in the market are now producing high precision drones. First with the Phantom 4 RTK, then with the M200 and 300 series. Later this year, we'll be introducing support for other high precision systems. And the way that we work with these high precision drones, RTK and PPK enabled drones, the device that you see on the screen there, what we call Edge 1, that is an RTK PPK base station, as well as a GPU that does photogrammetry processing. So what's really unique about SkyCatch is that in a single system, we provide you with two hugely important components of the drone data capture package. One is the positioning. So we provide that local positioning and support all different kinds of esoteric and coordinate systems. And then we also do the processing either in the cloud or in the field. So actually, it's great because we have users on the call. Kylan and Simon are both extremely experienced users of SkyCatch, who have been super users for a number of years now. I know Kylan uses the cloud system because his location has great internet connectivity. We can process data on the cloud and host it for everyone to look at. Simon, I know, is a big fan of the Edge 1, and on his survey vehicle, there'll be the Edge 1 mounted. He's flying the drone, and then that Edge 1 does processing in the field and delivers data super fast. So we've come up with a photogrammetry based system that works a lot like a LiDAR does, in that we give you the data straight away in the field. No need to sit down in front of a desktop and tag GCPs and post process. It's really all done as a single package. That data all ends up online, either in a popular mining software like MapTech, Vulkan, or sometimes in our data products on Data Hub. So as I said, I think this webinar really is about featuring our users and the mining surveyors who service all kinds of customers on the mines. So with that, like I said, Kylan as a US based, a Canada, North America surveyor who's been using SkyCatch for a number of years, and Simon, I'll really turn it over to you guys to sort of have this discussion around what do you think about as a mining surveyor, people, your internal customers, your stakeholders, and sort of your job as the people on the site who maintain good accuracy, right? Yeah, feel free to take it away.
Thanks, Will. Yeah, let's get into it. Let's have some discussion on this. Before we begin, and Simon, you kind of alluded to this earlier, maybe you both can speak to the type of mine sites that you're working at or that you have worked at, and the type of survey data that you've captured at those sites, and maybe the actual use case that you were capturing for. And Simon, if you want to start on this one.
Yeah, no worries at all, Michelle. So yeah, I'm currently working in an open cut coal mine, as I said, up in central Queensland. Prior to that, I've worked in an iron ore mine in Western Australia, but I think for this discussion, I'll probably focus more on just where I am at the moment. So our stakeholders, as Will said, vary from short-term engineers, medium engineers, geotechs, geologists, environmentalists, production supervisors, open cut examiners, stuff like that. So there's a huge array of people who we have to give the data to, and their needs do vary. So, but I suppose the main things I look at for the stakeholders, I suppose, is firstly, yeah, the data is accurate and it's also precise. So it has to be obviously correct and also has to be sitting in the right part of the world. The data has to be timely. So there's no point having this great data we can get, but takes days or weeks to process. So we need that really short, sharp turnaround. Probably that it's fit for purpose. So a lot of the time, the data from drones is amazing and it is the best type of data, but not always. And I suppose a really important thing is safety. So the data has to be collected in a safe manner. So you've got to abide by the rules and regulations of the mine site in gathering that data. So that's one thing that drones have allowed us to do. So it's taken us out of the pit to a degree. So we're able to fly from nice, safe areas and not have to have that huge interaction with heavy plant and stuff like that. So I suppose from where I come from, that's probably the main 4 points that I sort of see of importance for stakeholders.
So you spoke about some of the stakeholders, the geologists, the safety people. What is it that you're capturing for them? Like, what are they looking for, and what maybe just a couple of the different stakeholders that you have and what they're most interested in?
Yeah, okay. So probably one of the main people we give the data to is the short-term engineers. So they're really interested in knowing what material's being moved and how much material's being moved and how much more has to go and how much room they have left, say, in dumps and stuff like that. So the more accurate information they have, it allows them to make much better decisions moving forward. And that helps with planning moving forward. So again, the good data will allow them to make good decisions. So that's really important, I suppose, in the short-term engineering side of things. For someone like a geologist or a geotech, they're really interested in, geotech in particular, high walls and high wall faulting and geotech issues and stuff like that. So one of the systems we have on site allows us to do highwall mapping. Previously, we have done a lot of that work with a terrestrial scanner, but an example that just came up recently was we had a pit that we wanted to go back into. We got out of it originally because of geotech issues. We wanted to get back into it, so we needed to do a really good analysis of that high wall. We couldn't actually get into the area to scan it, so we were able to actually get that data using the drone system. So without the drone system, we might have had to put ourselves in a compromised position or not be able to get that accurate data to the geotechs to make the correct decisions. So
awesome. And Kylan, can you speak a little bit to the type of data that you're capturing and the stakeholders and what they're looking for from your perspective? And you're at a coal mine, correct?
Yeah, that's right. Similar to Simon there, yeah, I am at a coal mine as well, and that's where I've worked in mining is at the coal mine. And similar stakeholders, geotechs, geologists, planners, engineers, environmental, even senior staff, even auditors and third-party consultants. We get quite a variety of stakeholders, and there are a lot of people interested in the data we produce. So, everyone's got their own need, and we need to make sure that we capture the data properly and are achieving their goals and their needs, and make sure they're well taken care of. So those needs, they vary anywhere from mapping, geotechnical analysis, even just general survey tasks. For myself, using that tool has been quite handy, actually. And safety is a big thing, like Simon touched on there. And anytime I can keep my boots off the ground, I'm very happy to do so. It's not being lazy, but it's capturing better data and being safe doing it. And to me, that counts a lot. And those are my legs out there and my body. So so there's a lot of opportunity for their use, and we try to use it as much as we can. Yeah.
Awesome. So can you speak, Kylan, maybe when you're dealing with the stakeholders who are looking for the data, can you speak a little bit to the communication between you and that stakeholder, how that takes place? How do you ensure that you're getting what they need, and what does that look like?
Yeah, that's a good question. That's sometimes the question that people don't have the answer to yet, and that's where those discussions are good. Whether you're using screenshots, Google Earth shots, good pre-job discussion, and even examples of maybe what Skycatch produces to make sure they know what they're looking for before you head out in the field. Nothing worse than going out and capturing data that they can't use. So making sure they understand they know what they want, and so I can capture that data because it is going to help define what technique I'm going to use to capture the data. So yeah, very important to have that communication before I head out in the field, and for pre-job planning and safety and all the variables there. Definitely need to have that communication and understanding there.
And do they come up with some sort of checklist, or do you come up with some sort of checklist to say this is exactly what we're looking for, or is it just a shared looking at the map and saying we need the information here and here's how we're going to use it, this is how detailed it needs to be? How does that kind of communication look like?
Yeah, exactly. I think it's always nice to see things in writing, but and visuals there, so you make sure, right? So I would suggest that we don't have a checklist per se that we go through to confirm things, but just really good discussion, I think, is key there. And visuals, I feel, is really good. Everyone's going to be looking for different things, so there's a lot of variance to what they ask is. So yeah, just make sure before you head out, I'd say have a good understanding. Yeah.
Simon, how about you? Any advice in this area, or any best practices that you've seen or been involved with in terms of communicating with your stakeholders to make sure that they get what they need?
Yeah, I think basically what Kyle said is you've really got to communicate or find out from them exactly what they want from the data, what they need, because they'll sometimes just say, I just need a survey of this area, but you need to find a bit more detail exactly what they're trying to get out of and what they want to do with the data too. So, and also an important thing is finding out what accuracies and tolerances they need. So depending on the job, like the tolerances and the accuracies can vary by quite a lot. So sometimes it has to be millimeters, sometimes it can be centimeters. So I think that's really important before you start the job, is to find out exactly those things. And it also allows you to choose the best tool for the job, because sometimes, and the drone might not always be the best job, they might just need to go and pick up 2, 3, 4 points. So I think that's really important to find that out. And then also how much time, and I suppose not so much money in this sense, because that's more of a contracting side of things, but yeah, how much time they have for you to go and get this information for them and stuff like that, and the turnaround time they need the data back by. So.
And are there certain things that influence that time? Well, I think you might have a question that came in. Is that, I see.
I actually had a follow-up question for the two of you, which is when data is created, right? You're using different methods. How do you track, the accuracy standard of a piece of data that gets created? GPS rover will have different accuracy than a drone and a total station, and you have lots of tools at your disposal. So, it's all 3D data. How do you track sort of downstream? Like we can trust this data to a certain amount.
Yeah, well, on my site specifically, we'll use all these. Also, mostly compare it to existing data. So a good base for us is every month we'll get the active site flying with LiDAR. And that's usually a good base to compare all the data that comes in after that. So, for example, if we go fly one of the areas with our drones, we can bring that data in, compare it to the LiDAR data from the monthly flyover. And as long as that meshes well, then we're happy to move forward with it. So it's just comparing it to the existing data you have and making sure that it's meeting those tolerances and stuff like that generally.
Great.
Yeah, I agree with that. Similar to us, we have various sources of data coming in, so we can compare that way very efficiently just in the office. And the times that we do need to prove ourselves numerically, we will shoot checkpoints, but otherwise and monitor it that way. But yeah, generally the data we've found to get better and better, and it's very trusted data now. So not a lot of checking, and depends on what job you're doing though, and the need there, how accurate you need to be. So yeah.
Can you speak a little bit about that? Like, do you have any specific use cases where you say this needs to be highly accurate versus something else that does not need to be as accurate? Can you talk specifically to some of those? Kylan, do you want to take that one?
Yeah. First? Yeah, exactly. Like for us, definitely stockpiles, any volumetrics, we want to be accurate. If we're reporting a number that needs to be accurate, we're going to have senior staff, even up to auditors, and third-party consultants even looking at this data, and you don't want to provide them with inaccurate data. So yeah, it needs to be accurate. And the ask for us for that type of data was, better than 5 centimeters. And I got some good teammates and a good team, and we were able to accomplish that. And it's something I think our team's proud of, and we worked hard towards that. And yeah, the technology has come a long ways, and you know, from where we started with drones to the Skycatch system we use now, it's come a long ways. So yeah, I'll turn that to Sam.
Yeah, I agree. I think, for example, yeah, our coal stockpiles are highly important. So you want to make sure they're that sub 5% of accuracy, whereas out in the pit where you're just measuring overburden material and stuff like that, it doesn't need to be that accurate. So again, it's finding out what you need at the end and then using the tool. And for example, with the drone, you can fly at higher heights for your stuff that doesn't have to be quite as accurate. But when you want to get that sub 5 centimeter accuracy, you really need to fly at those low elevations and stuff like that to make sure you're getting those numbers you're chasing.
And what is the benefit to flying it higher versus lower, other than the change in accuracy? When you're not needing the accuracy, what's the benefit there?
Yeah, obviously, the higher you fly, you can cover larger areas in a much shorter amount of time. So it's just a time and a time thing, I guess. So if you want to cover a really large area quickly, you can put the drone up that little bit higher, cover the area. You know, it's still going to be within your tolerances in terms of accuracy, but yeah, just about to cover big areas and stuff like that, I guess. So.
And what are those type of captures typically used for?
Just overburden material volume calculations and stuff like that. So, or your week to week changes in the pit and stuff like that. So, yeah, that'll normally be within the 10 centimeter range, which is generally more than good enough for those sort of purposes. So.
And you know, given that altitude is kind of your main knob for tuning the accuracy, we actually had a question come in from Mark, which says, what is the best way to fly within the 400-foot limit with large elevation changes? Now Mark asked specifically about fixed wing UAVs. Our users are mostly using multi-rotors, but in the Canadian Rockies or in the Bowen Basin. How do you manage, flying with those big elevation changes in a mine?
Yeah, that's a good question, and there is some obstacles there, obviously, that you have to be aware of with the big high walls and stuff. And a lot of times you do want to capture data that's in that high wall, and so we will push our limit close to those high walls, but we want to make sure we're safe too. So using the gimbal camera and its capabilities allows us to kind of look at that high wall a bit better, or using the Highwall mapping feature if that's what you're looking at, right? So we do have a lot of elevation change. If you're worried about accuracy, yes, that's something that you'll need to consider when you're out there. Your takeoff height, and are you flying out over an open edge, and how far down below that, and are you trying to capture that data down there? Can be challenging. So you need to plan appropriately for that, and that can be a challenge, but it's not unsurmountable. You can definitely achieve the result you're looking for just with good planning, I feel.
And when you're doing the Highwall mapping, how important is the accuracy in that particular capture?
Yeah, very important. They're looking for high resolution there. So in the Highwall mapping, you're actually flying very close to the walls. So a lot of trust in the system, and the system's proved itself, so that's been great. But yeah, you're looking for high accuracy, high resolution for those geotechs generally, looking at those walls.
Anything you want to add there, Simon?
Yeah, I think a big feature of, the Skycatch system and a lot of other drones is just the terrain following features. So if you have an existing DSM of the area you want to fly, you can generally upload that, and the drone will stay that whatever set elevation, say 100 meters, for example, over the terrain. So as it goes up over a dump area, it will go up high over that dump area. Then as it comes back down low into the cuttings area, it'll drop back down low. So it'll always maintain that 100 meters over the areas you're trying to capture, and that'll always have a huge impact on the accuracy and the quality of the data comes out. So that's a huge feature of the systems, and something that really helps on the accuracy side of things.
Awesome. Can you guys talk a little bit about, besides the drones, like what are all of the tools that you're using in your survey process, and what makes sense where and when? Simon, why don't you take that one first?
Yeah, no worries. So basically, when our survey trucks will have a GPS unit, which is connected to an RTK network, so we can get real-time positioning. We've also got a terrestrial laser scanner, and we normally have a drone system. So we have both the quadcopter drone systems, we also have fixed-wing systems on site. And as I said, basically, when someone goes and asks you to survey an area, you'll find out what they want and the kind of data they want back, and you'll use the best tool for the job. So prior to having drones on site, our main way of capturing data was using a terrestrial scanner, which at the time was amazing and everyone loved that type of data. But then since implementing the drone, that has gone from being used 100% of the time to being used 10% of the time for specialized jobs and stuff like that. Whereas sometimes, as I said earlier, you've only got to go out and get a half a dozen points. So the GPS system is still the best system to use for that. So again, it's just really the type of data you want to get at the end. It makes you decide on what type of equipment you want to use.
Kylan, do you have anything to add to that?
Yeah, it's pretty much the same here. Yep, GPS, LiDAR, drone, total station. Hopefully it's hidden away somewhere. We don't have to touch it, but yeah, those are our tools. We even have a GIS enabled app now that's been pretty effective for us as well. So yeah, the progression has been come a long ways since I even started in the mine survey. And GPS, is good for its uses, and but slowly I see it disappearing in my use case from a daily basis. But definitely we need it out there. The LiDAR has its benefits as well. Yeah, we still use all of them, but the focus more now is towards drones and GPS support.
And we got a good question from Courtly, which is, how are your deliverables reported? Is the final handoff in report form, or is that up to the requesting department? So I guess that's how you really pass the data on to your customers.
Yeah, it's kind of how they want to see it, really. I'm the data capture guy, so I'm going to provide that data, and hopefully someone's going to make it look pretty and present it. But yeah, for me, it's just capture the data properly, have that conversation, see how they want to see it presented, and we have various outputs we can provide for them and deliverables there that we can provide, and hopefully that answers their needs.
What about you, Simon? I think you manage a mine master model, right?
Yeah, so we have for each of all of our active areas, we are constantly updating, I suppose we call it the point cloud or the model. So as I think I said earlier, every month we'll get all the active areas flown with LiDAR, and that starts as our base. And then for that whole month, we'll just continually add to that data and continually update that model. So that generally, as I said, comes in the form of a point cloud, but we'll also do things in basic AutoCAD or CAD form and stuff like that too. So drill preps and stuff like that. So, but it's mainly just maintaining that live, or not live, but updated model as you progress through the month, and then the next month will start again. So we'll do the whole flight on a weekend, bring that data in, update any things that change, dumps, dig areas, and keep that moving forward.
I think, Will, you had a question earlier when we were talking about the use
related
of
to
PCB.
actually this is related to the altitude, I guess, for Kylan and for Simon. Which Alfred's asking, which altitudes do you consider high or low in flying? And we'll do that in meters. I'll translate to feet for the Imperial users here. What's a low altitude flight? What's a high altitude flight in your context?
Yeah, for us, the 120 is kind of the limit, so we're going to call that high. So that's high. So that's the limit you want to stay in when we are flying out there. But if depends what you're up to too. Again, that high accuracy, yeah, you drop it down a little bit lower, and we have kind of that sweet spot there, and we found it kind of around that 100-meter mark allows us to capture a lot of data, our big pit areas, and still be efficient and provide that accuracy. Also, we've had some requests, some 3D modeling type requests where you're going to maybe drop it down even lower, 30, 40 meters over top of the infrastructure you're maybe looking at. So yeah, different use cases there require different heights, I would say, but 120 is the highest because that's what they let you do. And then yeah, I try to not get too much lower than the 30, 40 meter mark. Yeah.
And so that's 400 feet max, like same rule as we have in the US, and then 30 meters is around 150 feet.
Yep.
So yeah, good for obstacle clearance. And with this terrain, actually, a question came in. I think it's a cool feature, but I'd rather have one of you talk about it. Does the Highwall Mapping solution have a terrain following workflow to maintain consistent resolution? And also, we got asked, does the gimbal camera get dynamically angled? So I think, Simon, I think you've been a user of this, most recently.
Yeah, that's correct. So again, like I said, with the terrain following, so if you did want to do a highwall mapping flight of a particular area, you would upload a DSM of the area. So you had up-to-date terrain, and what the drone will do is, depending on what elevation you set it at, say for example 50 meters, it will fly over that terrain at 50 meters. So when there's a change in elevation, it'll read that and it'll move to that change. And yes, the camera then will also read that change and pitch and to that right angle to capture the best focus on the area you're trying to capture. So it's always getting that best angle of capture as it's flying over the area. So it's a little bit scary when it's going up and down high walls, but it's quite an amazing feature, and the results are pretty good. Very good.
I got to ask, Kylan, have you had a chance to use that?
No, I've seen it in action a few times.
Okay.
I've seen the result. I know it's a new feature, and so yeah, I'm looking forward to doing that. And I've looked through it, but I haven't flown a flight yet though.
It's you mentioned the 30-meter altitude, and I witnessed this a couple of weeks ago, but it's pretty cool to set a 30-meter height and then have the drone climb up like a 100-meter wall, maintaining that at that altitude the whole way.
Yeah.
Awesome. Another question that we had from earlier about local coordinates. So have either of you worked with local coordinates, and how does that impact what you do and your setup, and what does that look like?
Yeah, so my site that I work at's, I suppose it's a bit of a bastardized Australian grid datum site. So it's quite old and it is localized. So what we're able to do and easily do is just have a localization file created, which for the edge is just a simple CSV file with a list of coordinates in both WGS84 and also in the local datum. And what you do is you fly the drone, it'll capture the data in WGS84, it'll apply that conversion and spit the data out in your local site datum. So it's very simple, very easy, very quick. So yeah, it's really great.
And Kylan, anything from your side?
Yeah, no, same thing. We're a local coordinate system too. I'm not sure how it was put together, but it was a challenging one. But yeah, Skycatch supported that, and we were able to come up with our accuracy. It wasn't too big of an issue. In the civil side, some civil work I've done, pretty easy to plug in just that CSV file or TC3 file into the edge, and it's pretty fluent that way. So yeah, it didn't cause us any issues, and it worked very well.
So both of you, so Simon, you mentioned that you work a lot on doing your processing on the edge, and Kylan, you do a lot of the processing in the cloud. Why those two different options, and how are you ensuring that what you're capturing is exactly what you need to be capturing and the accuracy that you need? Kylan, I think you're in the cloud, so.
Yeah, so the cloud for us works well. We have remote access to our base station that is logging constantly, and has a solid power source. So it's up there, it's doing its thing. So we can tap into that and grab its log files. So it's convenient to us to go out, capture that data in the field, come back, use those log files to process the data. So there's some time challenges there sometimes if you wait to go out in the field to come back. So sometimes when we get back, we'll run subsets of targeted features from our capture. So if we were to fly our whole pit, maybe we come back and take 20 or 40 photos out of there and process that way to try and gain our speed back that way. So we've got some different ways to do it. We like to also have that data in the cloud to present. There's great visuals. We have access for everybody to all that data. So we'll get that feedback. If it's not good enough, then we'll get that feedback then, once we present it. So generally, you have that understanding before you head out what you're going to get, and so you can satisfy that need. But yeah, the cloud works good for us. I've used the Edge too, and it also has a lot of great function to it and use case too. And I think if you need that speed, that Edge is awesome. You can hook it up, and we all have the GPS with us. Screw it onto our truck, take that shot and get it rolling, and you can gain that speed big time there if you need it. Yeah.
And Simon, you mainly use the Edge, it sounds like.
Yeah, I think I'd use the Edge probably at least 9% of the time, and it really comes down to just that turnaround in time of the data. A lot of the time we'll get a request and they'll want the data ASAP. So the Edge allows us to go out there, do the flight, immediately in the field, upload that data from the drone into the Edge, start the processing, depending on the size of the flight, within half an hour, usually a lot quicker than that. By the time you get back to the office, the data's been processed. You have a LAS file you can import into your preferred system. We use MapTech Point Studio, compare that to existing data for validation, and then you can send it straight out. So within an hour, you could have captured the data, processed it, checked it, and it's to the guys who want it. So it's more around just that quick turnaround time. When that doesn't have to happen, we've got a bit more time, we will use the cloud, because it allows you to take out the step of using the Edge, and it's just to do the flight, upload the data, and by the time the next day, the data is ready to go. So it's just around that turnaround time, how quickly you want the data.
And do either of you get involved in, once the point clouds are created, putting them into different software, or is that your stakeholders that are doing it, say MapTech or things like that? Are you involved in that, or is that something that the other people are involved in?
So we'll normally bring it into, as I said, for us, we've used Point Studio for the surface creation and validation. And then once that's done, we'll export it and generally put it into the desired software of whether everyone's using, or just send it as a DXF and stuff like that. So we'll use a secondary software which will upload into, and then people can grab it from there. So, or if someone just wants a DXF, we'll just spit it as a DXF. So it's really, again, who wants the data and what format they want it in, we'll export it as.
Okay. And on your side, Kylan, do you do that the same or a little bit different?
Yeah, similar. Point Studio again there. Yeah, exactly. So yeah, we use some third-party softwares there to support us there, but also sometimes you don't need it. If you can avoid a step and just kick out that straight DXF, that's an option too. Sometimes there are some people just want the point clouds to come in raw, so the LAS files just as they are. So but generally, yeah, they go through Point Studio or a third-party software there to manipulate a bit and present properly.
Okay, I'm curious. And Simon, you might know this more, just because I think you've done some capture over here in North America as well. Are there differences based on where you're located? Meaning, in Australia, the process that you use or how you go about doing it has to be different for some sort of reason, or is it pretty much the same across the board?
I'd say it'd be very similar. You might just have slightly different aviation or drone laws, I guess, but obviously Australia has CASA that allows you to fly certain ways and stuff like that, but I assume North America is very similar. But the main thing is just getting that data out from WGS84 into the local or datum that you're working in. That's probably the most important thing, but yeah, I'd say that's about it. So
okay.
And,
yeah,
and
we
I've
have.
heard, I think in North America, the drone flies like this, and in Australia, it's like that, right? Actually, we got a real question, which is, do you have any influence on the point density of the produced cloud, and do you have applications that need different point densities? So actually, Simon, I want to point that one at you because I know the Edge kind of offers you this option.
Yeah, so with the Edge, there's some default settings you can select. So in terms of the quality, there's low, standard, and high, and that's just on the photogram. Actually, Will might be able to explain this better, how the photos are stitched together and stuff like that, the amount of time taken and the quality of that. And then there's also the density. So there's also low, medium, and high. I believe low is 4 points per square meter. Standard is 16, and then high is 64. For probably 80% of the things we do, we'll process on standard and low density. And then even after that, we'll still take it into Point Studio and filter a lot of those points out, because 4 points per meter is still a lot of points. So, and again, that really comes down to what you're wanting at the end of it. So if you're just wanting a standard pickup, standard low is more than enough. But if you want something with a bit more quality and a bit more density, you can go high, high. So again, it's really just coming down to what you want at the end of it, and you'll choose those parameters based on that. So, and that will affect the processing time too.
For a facility as big as yours, and I think it's at over 20 Ks long, is that right?
Yeah, 20 to 30 kilometers, I think, from active areas. So there's, yeah, it's quite a long pit.
So I can see why 4 points per meter is a lot. But what is a high density application? Like what's an application where you'd crank the edge up all the way and get high density?
Something we started doing recently is doing a lot of flights over, say, incident areas. So you really wanted to pick up a lot of that detail, both in, say, for example, tire marks on the ground and stuff like that, or where machinery is and stuff like that. So it's generally a smaller area, so you can really crank it up and get that high density, and that the processing time isn't outrageous. So again, it's just, if you're really wanting that density to really pick up really finite features and stuff like that, that's where you'll ramp it up and go those high densities.
Interesting. Well, do we have, is there any other questions that make sense right now, or should?
I think let's, we can hit this last bullet, I think, and then maybe we'll let our users get some more questions in before the top of the hour.
Awesome. Okay, so talking about the future, you guys have seen a lot over the last few years in the transition to the uses of different tools, including drones. Curious as to your thoughts on what the future holds for 3D data, maybe on the capture side as well as on the use side, and what the requirements may need to be in the future and why. Kylan, I'll let you start with that one.
Yeah, I think as we've seen, the progression has been pretty quick here. I feel we're out of the infancy now of drone technology. We're able to do some pretty cool stuff. So I do look forward to the future. I think in Canada and elsewhere, beyond visual line of sight's coming to fruition in places, and I think we'll see that coming to mining scenarios here soon. So I'm excited to see that range increase and see what we can do there. It's gonna be pretty cool. I know the mine I'm working at's transitioning to autonomous mining, so robots haul trucks. So I'm interested to see how that can complement that system and fill some gaps there. And so there's a lot of progression there, and even machine control systems and remote work and remote access. The use of drones can really be the eye in the sky for the people that can't be there. So I think we got a bright future in the world of drones, and I think being able to provide that high accuracy data and complete package data has been a big difference maker in mining and in my job especially. I'm very thankful for the tool. Yeah.
Very good. Thanks. And I would love, so I mentioned that we're going to be doing monthly series like this. One of the things I would love to get into a little bit with some people is the autonomous side of things, and the connection between the drones and autonomous equipment, because I do think that's definitely the future. So yeah. Simon, any thoughts from your? I'm sorry, I thought, were you going to say something?
I'll add to this actually, which is a question. In addition to what Michelle said, Simon, what do you expect, or what would you like to see with drones in the future?
Yeah, I suppose the main thing is that you want him to be able to cover larger areas and also just process the data more quickly. So I think that's, I suppose, the limitation at the moment with that visual line of sight. You can obviously get beyond visual line of sight and stuff like that, but then the larger areas you're capturing, the longer it takes to process and stuff like that. So I think once that improves, that's going to dramatically change the way things are done. I think we'll look at eliminating manned monthly flyovers and moving more from a static model to more of an active model. So both with drones and every bit of machinery that's constantly feeding data into this live model. So, and we're more of just a validator of that model moving forward. So, because I know, for example, on site, we've got drag lines that as they dig, they're scanning, picking up the material that's being moved, and that's happening with dozers and shovels and stuff like that. So yeah, moving more from that static to that active model.
Mm-hmm. Great.
And I think, yeah, what Colin said, just getting people out of the pit, I think is a really important thing. The less people in the pit, the better with autonomy and stuff like that. So.
Great.
And you're thinking mainly from a safety perspective when you say that.
Yeah, definitely. I think from a safety perspective, it's a huge thing. So the less people in the pit, the less chance of incidents and stuff like that. So, and drones is just one of those things that helps move that forward.
Another big topic besides the safety, environmental. Any thoughts on the impact of the use of drones on environmental? I know more recently they've been used for tailings dam monitoring and things like that, but any thoughts on the connection between the use of this type of technology for environmental concerns? Kylan, or?
Yeah, I think I think as the use cases expand, for sure, whether it's the tailings is a big thing for us too. So monitoring those tailings facilities and, just even infrastructure there as well. And then the wildlife around the mine is always a concern. Water management's a huge concern. So understanding, where our water is going, where it's coming from, is a big thing. And as we progress in this world, the environmental concern gets bigger. So I see a lot coming in that area as well here in the future. Yeah, for sure.
Very good. Simon, anything from down under?
I think it just allows you to get information more remotely, so you don't need to go into areas that are maybe environmentally of environmental concern. So you can capture all that information without actually having to disturb areas. So that's an important thing, I think, too.
Very good.
That's a good one. We got a last one here. This one's an interesting one. Any experience doing underground mapping with photogrammetry for either of you guys? I know that we're not really flying drones underground yet, but are you hearing anything, applications in underground mining and photogrammetry?
Not so much on the photogrammetry side of things. I know there's a big push for the LiDAR drones underground, but not so much on the photogrammetry. I haven't heard of anyway myself. Okay.
Yeah, photogrammetry is very lighting sensitive, right?
Mm. Yeah, correct.
Great.
Any,
either
ahead,
there. Yeah, sorry. No, not for me either. Will, I haven't had any experience or exposure to that underground photogrammetry. No, sorry.
Sure.
Well, it looks like we're coming up on the top of the hour. Are there any other questions, Will, that we haven't addressed here that we should be talking about?
I think we're mostly wrapping up. We got a couple last ones here. Can your drones fly in class 1 explosion risk areas? So this would be depending on the type of drone that you're using. So I know that I used to work in oil and gas, so I'm a little bit familiar with the question. It's around, intrinsically safe electronics. And so some drones, some of the DJI drones have been certified as intrinsically safe. Like, for example, I believe I saw the M210 was. So it depends on the kind of drone that you're using. And, we're really happy this year as Skycatch to not be only supporting, the systems that we've designed, but a lot of the, we're supporting all the new DJI high accuracy drones with more coming later this year. That's on that, we've answered all the questions. I think it was a great discussion. I'm fortunate, again, Simon, we've had the opportunity to sort of to work in the field together. I'll never forget, watching that kangaroo like hop across the dump and go off into the bush. Kylan, maybe there's I don't know what kind of crazy, maybe there's a Bigfoot up near you, but it would be great to I hope we can connect with the sort of stress of the pandemic lifting a little bit. I think we'll be at Skycatch we're all about getting in the field and really living the experience with our customers. So thanks for giving us that opportunity. And, I think what you've done is painted a picture for all of our attendees, to think about, okay, what is surveying like at the coalface. So thanks for that, to you both. And I guess I'll just hand it off to Michelle for,
Yeah, no, I really appreciate you guys spending your hour with us here and sharing your education and knowledge on not only drone technology, but surveying in general. So thank you, very informative. Just want to let everybody know that, again, we're going to be doing this on a monthly basis. Our next one will be on May 25th. And head on over to our blog. I have a special relationship with our blog, so head on over to our blog. We're doing a lot of great, especially mining content there, mining drone content. So please feel free to register for our newsletter there. But really, thank you everybody for being here today. If you have any questions that we did not address, feel free to reach out to me or anyone on the team here. I think you should probably have my email. If you don't, you can